Okay. Yeah, we're a little bit after 7:30, so we're not going to wait. If you don't know me, everybody here does. I'm Cherish Deaver, and I'm the Pathogenius rep for Baltimore and Harford County. Daryl is my coworker. He is in PG and Arundel and some other Southern counties. And our boss is Kim Clark, who's sitting right here right on the couch. She represents Maryland and DC, Delaware, Maine, Virginia, West Virginia. So if you have colleagues in those states, so you can see someone from Pathogenius, meet them up, connect them with her. And Rick is the director of commercial operations, right? So everything on the testing side as far as Pathogenius goes, they're really a whole big research laboratory. And he's going to be giving a presentation tonight. I want this to be really interactive. I think we have a really good group here, and I went to dinner last week. I want it to be more interactive than that. I feel like were you there? I was. Yeah, I want it to be. I want to be very interactive. So please speak up if you have questions. Nobody's going to be able to answer better than Rick. So okay, and Kim. So please speak up if you have questions. I know our questions are shared thing. There's a good mix. We have people here that use this, people here that have heard, and don't use this, and then people here that have never got a cat, you've never really heard about it. So this is your first time. So it's a really good mix, and that should bring about some good discussions, and we should make some good forward progress. So on that note, if you can go around, does everyone know each other? Like, do y'all know? Can you tell us where you're practicing? Everyone, you got your own, you're not making this from the couch. Agreed to do a swap. I don't know.
Okay, we'll do one.
He told me it's going to be his own toy. Actually, I still want to go around the room just so that everybody does know each other. Dr. Armstrong, can you start and say who you are, where your practice is located?
Where you went to high school?
Yeah, my brother. I'm Alicia Armstrong. My practice is on Pikeville. Was in Pikeville. I'm practice Road, and I've been there since
Well, show yourself. I'm sorry.
Robert Wagner, I'm a total bachelor's surgeon in Southern Maryland.
Daryl Cox, I'm with electronics. Eric Dunn, Williams Mills,
Spear, Reisterstown, Columbia, and Lucas.
Location near you.
Yeah. How can we say all your locations of your practice?
He's more humble than I am.
Yeah. You had how many practice locations you have for? Oh, Dr. Young says he feels terrible. He already threw a photo and he forgot. He's sorry.
I told he wasn't coming. I come back.
I might actually have to have him checked if we get a thing like this.
Yeah.
I told you he wasn't.
He feels too, probably. I don't talk to Dr. Gerson like that. Yeah. I'm gonna tell him to turn around. No, it's okay. We'll put him on the DVD. Yeah. DVD. He'll be on YouTube. Yeah. Alright. I think we're good.
Okay.
Rick, get started.
Well, I don't want to be between you and the red meat, so I'll try to get you this quickly. Everybody comes for the meat. What I want to do tonight is just kind of give you some background on Pathogenius, and I hope what you'll find is a huge change in terms of diagnostics for medicine, and moving from a diagnostic tool that you've only known and ever known as culturally to a new diagnostic tool that I think you're going to find exciting. It has huge opportunities, and hopefully we'll go through and give you background on Pathogenius, how it started, and a little bit of understanding of on the microbial side why DNA diagnostics is a better tool for understanding what you're up against when you're treating infections. Pathogenius was started by a guy named Dr. Randy Walcott. Dr. Walcott is a nationally known opinion leader on biofilm research, and he also manages an extremely large wound care center in Lubbock, Texas. It's probably the largest wound care center in the western side of Dallas, and that has patients coming from all over the Southwest to see him for the reputation of saving limbs. He initially became involved with the whole biofilm research in the early 2000s when he was faced with chronic wounds that kept coming back culture negative, and knew that bacteria was a huge issue with these problem wounds, and started working with people like Dr. Costerton, who's kind of the father of biofilms. Costerton started the biofilm research centers in University of Montana, USC, and then lastly in Pittsburgh. So I'm going to show some of Costerton's work. I find it really interesting, hopefully you do too, in understanding how these bacteria behave in these chronic infections. But we do molecular not just for bacteria, but also for fungal and viral. I'm talking with the viral. The first I'd like to kind of start with is what I find most physicians, in terms of your micro background, and what we learn is that the concept of how you identify bacteria was based on Koch's principle of growing it in a petri dish or medium, and that was based on single-cell planktonic bacteria. So here we have staph by itself, which will, if you drop it into a certain medium, it will grow. And it's almost a selective bias. They like the medium, and they will grow. But it was originally designed for planktonic bacteria. They didn't understand that bacteria didn't always behave just in planktonic form. That bacteria realize that if they don't quickly move to a combine with other bacteria to form complex colonies, that they would die. I'm going to show a little clip from a couple of top microbiologists on that. So what we think this is what causes acute infections. So strep is an acute infection caused by a single planktonic bacteria. But in chronic infections, what we now know is that these staph quickly move to join other staph and other species of bacteria to form complex colonies or biofilms. And go ahead.
Define chronic. What do you consider chronic?
Chronic would be based, I would say, in a wound environment or a sinusitis. The wound, as soon as you see the wound not progressing, once it stalls and you don't see progress, then it's moved into a chronic stage. No, it's very host dependent. Because, age, diabetes, vascular, all the other things that we know and keep healing. And that's what the bacteria will take full advantage of. And I tell physicians that, you have to first look at the host factors, then look at the total bacterial load, and then start looking at the species. So what we know is chronic infections are caused by these complex colonies. Our business started with a focus on wounds because Dr. Walcott is a wound guy. But our sample volume is growing faster than in other areas outside of wounds. So ENT doctors with sinusitis, urologists with chronic UTIs. So we're getting a lot more business from other specialties now. So these cause 80% of infections. That's been well documented in the research. They are what cause the chronic infections. And what we now know is that once they move from this Staph aureus here in a planktonic form, once they go into with other bacteria, they change phenotype. This was work that Costerton did and showed that once they changed phenotype, they became almost hardwired together. They became from a single cell to a single community. And if you try to rip them out and put them in a petri dish to grow, they will not grow. So when you're getting...
It's 80% of chronic infections for the biofilm.
Yes.
Not necessarily acute infection.
No, chronic. So if you try to tear them out of their community and put them in a media, they just simply will not grow because of that change in the phenotype. In fact, that they become literally wired together. So that's where, but the big challenge is here you can't grow them in a traditional diagnostic tool that you've always had, culturing, but they all have DNA. So if you can remove them, you can identify them from their DNA. So that's where the whole advantage comes from using DNA diagnostics versus trying to grow bacteria. So this is just one of the chapters that was out of an orthopedic textbook that Costerton was one of the authors. We can give you copies of these. There's actually two chapters in this textbook that address this whole concept. I'd be happy to share those with you. I'm going to kind of go through some of his work. Often, you guys do wound care, so this doesn't bother you. But when I'm talking to physicians about the value of using molecular diagnostics, if you just kind of think all wounds have bacteria and I can kill them by just the breeding and I don't do cultures, then I usually say, well, I'm not going to waste your time. You're not going to be interested in this technology because you don't use cultures and you don't think bacteria is a problem and you can solve it with other means, then who cares about molecular diagnostics? But we know that this hole was created by bacteria. This communicated through this was on the lateral side of her heel, communicated through her foot, and all this slough, which we know is basically what the complex that the bacteria produced in these colonies. They need this. And the maceration on around it tells you have a lot of exudate. That exudate is what the bacteria produce, that matrix that they have to live in and survive the nutrients. So you put dressings on this that trap it, they'll love it. They'll grow and they'll flourish. If you put dressings on there that will break it and absorb it, they'll die. But again, we are fastest growing areas are ENT docs, and they're dealing with biofilms in the ears and the sinuses. We're just starting a large trial, a study with Dr. David Kennedy of the Penn. He's kind of like the national guru on the ENT side, and he's done most of the work on sinus surgeries, and he's going to be doing a study similar. I'm going to show you what we did in wounds. Bacterial vaginosis is another one, OBGYNs. This was just one of the infections that Dr. Costin brings out in orthopedic infections in an infected elbow after 5 years, multiple 7 surgical procedures, culture negative continuously. They use PCR technology to identify microbes.
How would culture show negative?
How would they show negative? Because remember, once they go to a phenotype from a planktonic into a colony, a biofilm, they won't grow. So you can't get them to grow. When you get a culture result back, you're getting this. I'll show you the future slide. But basically, the colony is constantly sending out fragments.
So you're getting a positive gram stain.
If you get a great positive gram stain, you capture a planktonic bacteria, or if you're getting a culture result, you're getting it from a planktonic.
The gram stain could still be negative. Right. Because if you look at the picture he had, depending on where you take the sample from, it could be negative. Because it's not diffuse. This is a pick and choose where they live kind of situation.
Did you sample? I tell us where you sample from. What I'm going to tell you is there. If you take a sample from only one part of the wound, then I'm going to tell you what's in that part of the wound. If you take a sample from the entire wound, then you'll get a much better diagnosis.
I was just thinking of the entire
Yeah, we see that a lot. You see that quite frequently. And then once you take the implant out, then you realize when you can culture the whole thing, then it will work.
I took out 2 slides from orthopedic from the top of on the hip because they kept coming back ultra negative, and then when you use sequencing on it, we found a lot.
So is there any biology mediated separation of DNA sequence found differences in the native strain?
Oh yeah, we regularly find, and I was in the lab once and was watching some pretty amazing watching the process of the sequencing. It's linked to a massive database in the NIH, which holds all related to the Genome Project, where they actually map all this out. So when you watch it sequencing, then all of a sudden it'll pop up and say new.
unidentified, which is basically a subspecies from another one. Not that they end up being in the same host family or family, but they regularly find genetically.
If there's a bacteria that's identified and then on the antibiotic it's unknown species, what do the doctors do as far as treating it? If they call the lab, or they just
we're really dependent on our database of microbes and what the research has shown is effective on those microbes. So it can happen where we'll find something that, especially on the fungal species, that there'll be nothing identified as an option. And then we basically have to start looking for Googling and looking for any research paper we can find where that species was found and where they used effectively to treat it. So that's I actually had a call from the guy in Nashville. He was talking to the culture lab. We're going to talk about sensitivities, but even some of the culture labs are not doing sensitivities anymore. They're using research-based sensitivities.
So they should call the lab if that happens.
Yeah.
Okay. And it's a research process.
Okay, so other perception that people have when they talk about molecular is they think, oh my God, this is going to be really expensive. And it is. But it's a volume-based business. So the more samples you run, your cost per sample will come down. So if we were just offering you as clinicians this opportunity, we wouldn't be in business. It would be cost prohibitive. So it wouldn't be a viable model. Which is the barrier why people say, oh, our hospital has molecular. Well, they have a PCR machine that does Staph aureus. It's a single PCR that you can buy. You can say, and hospitals are buying them because they want to screen everybody coming in the door for MRSA. So the easiest way to do that is to buy a PCR for a single for MRSA, and you can quickly tell, is that person carrying MRSA or not? But it's really limited to only whatever you ask the machine to go look for. High-res sequencing to sequence against 13,000, the hospital can't afford to do that, and which is corporations can't do that either. So the reason why we can offer it to you is because we have a large volume of samples that we run. And our volume of samples are coming from our research side. So we do a lot of samples for corporations. So everybody from Procter & Gamble, Johnson & Johnson. So I always start with, why would Procter & Gamble send us samples from their research? What do they make? Soap, cleaning agents, which they're trying to figure out, their scientists are trying to figure out, is this compound going to kill microbes? Toothpaste. So the first symposium that Dr. Walcott went to on biofilms, there was nobody from medicine there. It was all corporations. The corporations were spending a lot of money trying to figure out how to kill these microbes. So if you look at your toothpaste, you're going to see lactoferrin, xylitol. These are all things that act on these biofilm complex colonies when they go through their form sensing, their fragmentation. They're trying to figure out how they can inhibit these guys from continuing to prosper and grow. So when they want to develop a new product, they're not going to send it off to the culture lab and say, how did we do? Did we kill anything here? They're going to want to have access to DNA sequencing. So we do all of their research. J&J, Medtronics, they are in a lot of areas, but one area that we work extensively with them is on their sinus debridement tools. So they're developing a new sinus debridement. They send us their samples from their research to say, post free samples to say how effective their sinus debridement was at removing biofilms from the sinuses. The one that Dr. Walcott's most proud of is NASA. When NASA started sending us components to the Mars rover Curiosity. So they're spending millions to send this rover up to Mars. They wanted to make sure they weren't sending microbes from Earth up to Mars. So they didn't send it off to a lab to do cultures. They sent it to us to identify if there were any microbes. And the lab was all nervous because it was pretty secret. They didn't know. They said, well, we can't find anything. And they said, well, good. That's what we're hoping for. The U.S. military, we do a lot of big contracts for the Army. Even Mayo Clinic, large university academic centers. Anybody who's doing research today and there's microbes involved, they do not use cultures as their metric or the measure of whether, in terms of measuring identifying microbes. It's culturing and it's gone. reason why it hasn't been available for everyday clinicians is, again, this cost issue. It was never commercially an option. Now we're making it available. Even the CDC sends us samples. They have pyro sequencing, but they don't have the expertise on the extraction process and the speed that we do. When you do thousands of samples, you get pretty good at it.
How many samples do you do then?
I only know on the clinician side, we're only 2 years into it, so we're up to about 80 to 100 a day. But I don't know the research side. It's heavily subsidized on the research side. So.
And I think it's interesting that CDC just come to us to put 5 data.
Yeah, we just contracted with the CDC to build 5 separate regional labs. They are following after our lab. So I was talking about research. This is just one New England Journal of Medicine. They looked at bacterial vaginosis. They used molecular to identify. And this is really interesting because they always thought they had the pathogens identified which were the causes of bacterial vaginosis. All of a sudden, when we looked like it, we were like, oh, we were wrong. There's a lot more in it than we realized. For you guys on the foot side, this was published. This was sponsored by the NIH. I was talking to Dr. Rob Schneider. I don't know if you know that name. He's down in Miami, but I didn't know Dr. Gardner, but he was all excited about Dr. Gardner. He's at the top of the field, and then there's the name on there. But this looked at the microbiome and diabetic foot ulcers. They basically said that bioburdenism will lead to underlying delayed healing, and comparatively wound cultures, the standard diagnostic in the clinic, vastly underrepresent microbial load, microbial diversity, and the presence of potential pathogens. And they used sequencing and said sequencing was a far superior tool. So when Dr. Walcott first started, he was obviously in network with a lot of national opinion leaders, and they jumped on early to using our technology. So Carolyn Fife is the editor. She runs a large wound care center in Houston. She's the author of a textbook by Sheffield and Fife. It's the main, I would say, in terms of wound care, the go-to textbook. I'm going to any of you know Dr. McGuire at Temple. He uses this quite often. Loves the diagnostics. Steinberg and Adam here out of Georgetown sent us samples. And then the ENT, Dr. Ferguson is at the University of Pittsburgh. And she's a top national opinion leader in the ENT. And then Dr. Lanza is also master recognized sinus surgeon, complex sinus procedures that he uses. So this is what I was talking about before, the stages that when you end up getting, with culture results, you get these planktonic forming, landing first and then growing, and then they disperse off of the colony constantly. Which is why, when you have a patient with an open wound, you don't bring them to the OR, because these fragments are going all over the place.
There's an increasing recognition that biofilms play a role in chronic disease. And the reason for that is that biofilms are very difficult to eradicate. They live on surfaces, they produce extracellular material that can defend themselves against human immune cells or antibiotics. And therefore, they're very difficult to remove. Once they form on the surface, they're very difficult for your body or for drugs to show them. So it's only been in the past really 15 years that the medical community has recognized the existence of biofilm bacteria as fundamentally separate and distinct from lionized bacteria. Bacteria come together when they're threatened. When you have a situation where bacteria are treated with antibiotics that can kill them, or when a strong immune system responds to bacteria by producing cytokines or chemokines or other agents that are able to destroy the bacteria to eliminate them from the body. These bacteria have a choice. They can either stay as individual bacteria and die, or they can change their form and instead of being a planktonic bacteria or biofilms. Acute bacterial infections and chronic bacterial infections are very different. Acute bacterial infections are caused by planktonic bacteria that are swimming freely, bacteria such as sickle cell. Chronic infections, for the most a chronicity versus we have done studies in which we have grown biofilms and tried to add, penicillin, gentamicin, some standard type antibacterial agent, and we're not seeing to. They are very difficult to eradicate because they don't grow rapidly. And most antibiotics kill organisms that are growing at maybe about 4 years that are not growing. So these organisms are faster in the area of who's in our belly. Endocarditis is a mild organism that not growing. Examples of this can include infections of bone, infections of the heart valve, infection of the urinary tract, which bacteria can colonize surfaces of the human body and live there for long periods of time. So what we know about these communities is that it takes such a greater concentration of antibiotics to get rid of them that it is not indicated. We're talking about anywhere from 500 to 5,000 times the concentration that normally is the minimum inhibitor concentration of antibiotic that it takes to kill bacteria. Usually biofilms and bacteria is quite close. Biofilms, because of the presence of sister cells, being able to trade genes between each other, can often have an increased level of antibiotic resistance. And so, moving forward, we have the technology the kind of research that we can do is to really focus on both of these problems. We have biofilms as well as the energy. We also have antibiotic resistance and how they interplay with each other to cause you. And what this says is that clinicians have to be much more careful and patients have to be much more vigilant about being in a hospital setting, about having surgery, because these are all times and areas where one can pick up bacteria that can lead to biofilms.
Okay, so I'm not a microbiologist. Those are some of the top microbiologists in the country from the previous academic centers. I covered a lot of what they said, but I just want to use this slide to talk about a few points on one sampling. If you have a wound and you take the slough on top, a lot of docs will say, well, yeah, of course there's a lot of bacteria in that slough. I don't want that. I want to know what's under the slough. I want to know the bacteria that's closer to the red granular tissue. So you can take a 4x4 and wipe that off and then take your sample underneath the slough. But if we also find, if you set this slough and we find multiple bacteria at high levels, and every week you come back and the slough is back again, well, I almost can guarantee you that what we're finding in that slough is down below too. But when you do sample, the cornerstone of wound care is debridement, and that was all based on Steve's work, where two groups, one got weekly debridement, one didn't. The group that got weekly debridement field test. So we know that when you disrupt these guys, they don't like, and that they're actually, Dr. Walcott has done research on looking at the window of vulnerability, and it's actually about a 2 to 4 hour window when you debride where the colony is at its weakest point. So if you hit it with biocides and systemic antibiotics, top antibiotics, at that point you have the greatest probability of success, which is why debridement is so important. But in 2 to 4 hours they come back to full strength again. So they're pretty resilient. And if you're taking a sample, if you take a sample from one edge, one part of the colony, we're going to tell you what's in that part of the colony. But it's kind of like the analogy of looking at a map with different communities. You pull from one community, we'll tell you who's living in that community. So the more communities you collect, the better diagnostic tool that we can give you. If you're an aggressive debrider, and you debride deep, and then you just take a little piece of tissue from an area where you went deep, you're probably going to get a lot of host DNA, and that's it. It's not going to be a very valuable diagnostic tool. Okay? We know that these colonies are taking advantage of this environment because why do people get wounds? They usually have vascular issues to begin with. The blood flow is not great. How does systemic antibiotics get there? They can't penetrate. They can't get high enough levels as one professor from Brown talked about. So these are all factors of the host that the bacteria will take advantage of it. Age, vascular issues, pressure. Just to show you how powerful these guys are, this was under electron microscope with biocides and using bleach. So this is exposure to 60 minutes of bleach. The green is dead, the red is still alive. So even when we see products that say we kill 99% of bacteria, well, they're killing 99% of a planktonic bacteria. Once the bacteria is together, you're not killing 99% of them. So even the iodines of the world, or the Dakins, the things you think would wipe out everything. When it comes to once they're in the colony, it's very difficult to do that. Obviously, once you cut into them, and breed and disrupt them, then they're much. So Dr. Walcott advocates to win the war against these guys, you had to hit them with multiple strategies. Debridement the cornerstone, but you hit them with biocides, like things with a chlorine molecule, like microcin. You hit them with systemic antibiotics, and you can hit them with topical antibiotics. This is the more controversial side, although it's becoming less controversial with podiatrists. It's still, with except for Dr. Warren Joseph, Dr. Joseph is still very anti this, but he loves our diagnostics, but he's not convinced on the topicals yet.
It's why Dr. Wagner's here. Dr. Joseph is, everyone else seems to disagree with him about this.
No, there might be some people here that would probably might not use topicals. I don't know. Okay, so what's the only tool you've had to identify what you're up against when it comes to bacteria? Culture, right? It's been around from Louis Pasteur, 1800s, and it's basically growing. Culture, the word culture means to grow. So what you're asking the lab to do is grow me this stuff. So we know from research it has about a 15% accuracy in wounds, so it's really not that great. And when you get a result back, it's based on, it's really what they were able to grow, not what's actually in the wound environment. And it's the planktonic bacteria that they're growing. Thanks. Now, this is also another surprise because a lot of podiatrists and a lot of physicians don't read the CID, the infectious disease journal. So, but in CID last summer in 2013, they published their national guidelines for utilizing microbiology. Whatever the IDSA, which is the Infectious Disease Society of America, and the ASM, American Society of Microbiology, they come together and say to clinicians, these are our guidelines. This was a 100-page document to clinicians to say, if you're going to use micro, there are certain things you as a clinician must do. The big issue was specimen management. So you're responsible for taking the specimen and getting it to the micro lab. And if you want them to be effective at their job, they're telling you you have to meet certain criteria. So specimen management, guess what much time they give you to get your sample to the lab? 24? How much? Any guys want to guess? 2 hours. If you're in the hospital, you have the best chance. You get it down the hall because it's an air conditioning. So it's in the medium, but even in the medium, we know that, but even in the medium, they say we don't care. Keep it at room temperature and get it to us in 2 hours. The reality of that is, this. So if you're in private practice, you throw it in the box. And I tell docs all the time, you wonder why there was no growth? Well, you sit outside for 8. I live in Orlando, and it's 90-something degrees. Come on, chance of. All of this is because of one main reason. That's because they have to grow the bacteria. All of this goes away when you start doing DNA extraction. Because it doesn't matter what temperature or time, we're extracting the DNA from that bacteria, so we don't care.
But if you live with dead bacteria, you don't care.
What's that? does.
Whether the bacteria is alive or dead, it doesn't matter.
Well, we get that objection a lot. They say, well, you're just going to tell me a lot of dead bacteria in there. If you're going to put the DNA from dead bacteria, so how do I care if it's dead, right? Well, we know that once you remove, the host does a great job of cleaning out the dead bacteria. So what the sample that you sent to us, the DNA we're taking from that came from viable bacteria. There's going to be some dead in there. There's going to be some dead in there, but the highest proportion is going to be live bacteria. Because the host has the capability to constantly clean out the dead stuff. And there's also RNA messengers that they can do. Pathogenius work, I'll leave you the chapter, talks about how they can distinguish between live and dead bacteria because of those messages. So they find those messages.
If you're analyzing DNA, how do you distinguish between live and dead bacteria?
You cannot distinguish between the two.
Right.
But what we know is that from research that there are messengers that you can pull from RNA messengers that you can pull from the sample that are indicated that only come from live bacteria. So if they're in there, you know that had to be viable living bacteria. We also know that the host is very adept at cleaning up the dead stuff. So once you remove the bacteria from the host, everything you removed is predominantly living bacteria. Because you've taken it away from the host and the host's capability to clean the dead out.
So you're saying that in most homes there isn't dead cells, bacteria, dead anything?
Well, it's a constant process within the host it not only within the host, but the column is basically eating the dead stuff. They're constantly, removing the dead stuff out. So that's happening regularly.
If that were true, then why don't you use maggots to try to eat the dead stuff? Because there's a lot of dead stuff.
But maggots are eating live bacteria.
No, I eat the dead stuff.
If it's eating tissue,
Yeah,
maggots don't eat the bacteria.
They're
eating tissue. They're not eating the bacteria.
Can be infected with viable bacteria.
It's the tissue that it eats. And the messenger
Dead bacteria?
No, the messenger RNAs, there are certain ones that degrade after a certain period of time. There are certain ones that they can degrade after 2 hours, degrade after 4 hours, degrade after 6. I don't know if they have the capability, but in research labs, you can tell this bacteria's been dead for 7.5 hours. This bacteria's been dead for 2 hours.
So you provide that information?
We don't provide it, but we have to validate our processes. So that's part of the research. All those companies telling us they want to know that too. So we have to be able to show them that what percentages are living bacteria versus dead.
So I think that's why we have a lot of negative culture. Someone's on an antibiotic, or there's dead cell, or dead bacteria. That's why.
No, it's actually not. You go back to that slide, right? The slide that in 2008 there was a study. They took known bacteria. We took plates of bacteria. I worked with Adager and Snyder. Known bacteria, scraped them on a swab and put them in, less than 15% grew. And you knew what you did. You knew you took it off of a grown healthy. That's the problem with swabs. Because swab is not healthy living tissue that you can eat. The problem is with swabs is that you're not giving them something to eat. If they can't eat in the next 2 or 3 hours, they're going to die. That's why they made it a 2-hour culture.
But don't take the swab and put it in some sort of anemia.
But that's not enough. Because if you have this biofilm, they don't need it anymore. They can't use this because they're altered. They need everybody else's help. And they need to feed off of the dead pseudomonas, their dead, So that's why you need to actually have a window. You need to have this biofilm capability.
The biggest thing though, that why they don't grow, why you get negative results, is because of the phenotype change. Once they go from planktonic to combining with other bacteria, it's like caterpillar here, butterfly here. Same thing, but 2 different things. So once the phenotype changes, they will not grow.
So are you saying, if I'm hearing you correctly, the biofilm changes the nutritional requirements of the original pathogen?
I'm saying that we know that we can look at phenotype of Staph aureus in a planktonic form, and then once we can look at the phenotype when Staph aureus combines with other bacteria, we know it changes its phenotype. So I can't answer that part, but we can answer the fact that we know there's a phenotype change, and that change causes them not to be able to grow immediately.
So which antibiotics do you choose? If it's changed the phenotype, does the antibiotic not work anymore? Or would you have to use the combination because the food package changed?
As the guys on the lecture, the scientists said, they put gentamicin and other antibiotics and did nothing. Biocide, I showed you the biocide, slide.
So really, you got there are choices and not.
You gotta hammer them with when you gotta do if your cortisol is depleting, you gotta disrupt them. And then you gotta hit them with biocides, topical antibiotics, systemic antibiotics, everything.
There's biofilm that's fine, I'm sure as well.
Yeah.
Usually not the acute form, usually there's not a biofilm necessarily applies.
What I'm curious about is that when you're talking about the diagnostic versus the treatment side of this, when I was going to my training early on in all those years, we basically dealt with the handholds. You then have sensitivity, which has no inhibitions. So you basically this is work on the and now this is blowing it all up.
Yeah.
Because you're telling me also that when you identify what the particular illnesses are, they're going to look, they're saying, okay, fine, those organisms respond to this particular antibiotics. So it's not really relative to what
It's not. It's relative to what you just described was a pythonic. When they measured antibiotic sensitivities, it was on pythonic form. Once it combined with other, and we had this actually at the Walton, the 6-hour CME, and you can look at one single bacteria, and then when you add one antibiotic, it destroys it. Once it combines with two, all of a sudden the antibiotic doesn't work. It can't penetrate. They work together.
It's not. I would disagree with that. I don't think it blows it under the water. I think what it is the next evolution. Because we are all what our DNA says we are. The bacteria are what the DNA says it is. So what they do when they go to the book is they say, okay, the DNA of this Pseudomonas says that he will be resistant to this or sensitive to this. So it is the zone of inhibition that we're used to seeing only on a molecular level versus on a growth level. So it's actually even more detailed than it was 20 years ago. Yeah.
But the problem is there's no such thing as contamination.
That becomes, I'll show you on the report. When you look at the 1%ers on our report, you don't know in that total mixture what is a pythonic or status in pythonic form, what came from the community. The 1%ers are the greater likelihood of what being contaminants.
What
We don't know how to
contamination versus that it's at NT6, NT7.
even that number, there's a lot of.
Everybody uses social.
Yeah, you have to look at homes.
Yeah, I use the wound disinfection.
Yeah.
Here's what I tell the patients. I try to break down the difference between colonization and infection. You invite 5 people over for a dinner party, and everybody has a great time and goes home. That's a colonization. You invite 50 people are dancing on the table, there's a great play on the overall, that's an infection. So if the wound doesn't improve, it's infected. If it improves, it was colonization. That's how I look at it. I don't take a set number.
You can use our PCR tells you quantitative load. And you can use that as your first kind of measurement. Look at the patient and see how they doing clinically. If the load is high, you're not doing well. There's a correlation. If the load is low and you're progressing, then it's like the body is able to host factors that are coming.
And as for contamination, I don't use that word because I tell patients the root is infection because of that. The infection doesn't come from your neighbor, it comes from your skin 3 inches away. So anything that I see, even the 1%ers, I treat because it's there anyway. And if I treat the 90%, then that 1% is now going to be 90%. So that's where I get that's why I treat it the way I treat it. 100% of the infections most of them come from down where their environment is different.
When I talk about blowing things out of the water, what you learn. Years ago, in the early 90s, I was selling antibiotics for Pfizer. And I used to sell an antibiotic called Unison and Tobacco. So you would go to doctors and say, here's the national surveillance data of diabetic foot wounds. National surveillance data, where did it come from? Cultures. As I said to Dr. Warren Joseph, well, we're going to turn all that upside down now because it doesn't correlate at all with what we're finding in diabetic wounds when we do DNA diagnostics. We're finding much more anaerobes than we ever realized. We're finding a lot more pathogens that the National Surveillance Day is narrowing down the shark. So, but people that are skeptic of this technology, what I ask them to do is I say, send a sample off to Quest or LabCorp, and then send one off to us. We'll do a parallel analysis of this. But make sure you take the sample from the same place. Don't take one from one exit margin and then the other from the other margin. Take it from the same area. Sorry, that's blowing heat on there. So we did a study with this parallel sampling. So we took 51 chronic wounds, and the 51 chronic wounds, one sample went to traditional culture, one sample went for DNA sequencing. So what's the easiest bacteria for the culture guys to grow? Staph. So out of 51 times, they were able to grow it 28 times. So in 28 of the 51 wounds, they grew staph. When we took the same 51 wounds, how many times did we find staph? 46. So they missed it, and the research shows that staph has a 50% probability of growing in cultures. And that's the best. Staph loves the medium. They grow. All its other counterparts, forget it. They don't like it. They're not going to grow. I just pulled 2 pathogens out from this study to show you the differences. So they were able to identify Pseudomonas in 8 of the 51 wounds. They were able to grow Pseudomonas 8 times. We actually pulled the DNA of Pseudomonas out of 32 out of 51 of the wounds. So this is huge for you, because what are you using this for? You're using this to make a decision on treatment. So you're making your decision on treatment based on what they tell you they can grow. Now you can make your decision on treatment based on the reality of what's in there. And remember the slide with the temperature and the time. If you haven't gotten there, these were all done with 2 hours of room temperature. This was that NIH study. I won't go into more detail on that. But the last summary point on that NIH study was these findings made important clinical implications justifying the clinical use of molecular approaches rather than traditional cultures. And so what we do is PCR. How many of you have heard of PCR? You guys have. So the guy who discovered this in the early 70s won the Nobel Prize. Polymerase chain reaction. It was the first entry to molecular, but it's a limited technology because you have to have primers to go out and say the technology go find Pseudomonas, go find staph. So we give you a PCR panel. Actually, this is not the wound one. This is the ENT one. To change the slide. But we look for 8 common wound pathogens, and we look for the genes that make MRSA. So staph became MRSA because of the gene. We can pick up that gene and tell you whether that gene is in that sample you sent us. Tell you whether it's MRSA. We're also going to be able to tell you, have you all heard about MRSA being community strain versus healthcare strain, right? That's also a molecular that we can tell you. So we're going to be offering that shortly too.
I have a question on that, and this is my little voice on here. So I'm getting a lot of, I just started with y'all, and I'm getting a lot of stuff coming back as, methicillin resistant on male samples one time. So then, of course, first thing I'm going to think it's me. So then I checked all my sterilization, ordered all this stuff in that, supposed to kill it, did the little swipe thing before I took my sample, it's still coming back. So my issue is now that, okay, you're ocean or whatever, because everyone's looking at us to come in and be like, you're a dirty girl. Dirty. Exactly. I'm figuring out and looking at this stuff, and now they're showing all my cases that I'm a dirty girl. So then I get the antibiotic for the nail stuff, okay? So now to get this stuff sitting in the house, the stuff with Baseline in there. And so I called the lab folks, and I'm like, is this normal? Is it me? What's going on? And they're like, well, 40%. I said, do you have any literature on this? They're like, no, not really. Okay, that's an issue. And they said, well, we running this might just be like, okay. It might be like a common flaw there. Now my issue is if it's, I'm sorry, my issue is now if it's a common flora, then and we'll prescribe linazolid, that's one of our heavy hitters, and now we're going to start antibiotic resistance because now we're putting linazolid and all these heavy hitters who are going to sell that community common bacteria. So what do I do? Do I stop taking nail samples? I'm kind of out of that limit because if we take the samples and we get it back, we have to treat it. What do I do?
Okay. First thing is, we can tell you, I can pull 1,000 reports, we can compile data, we can aggregate data, and I can show you how prevalent MRSA is in nails. So I can give you that.
It's going to protect me, or it's going to be something like it's only 2%.
Well, no, the first thing is, I mean, whether to protect you, no. I mean, the fact is, if versus in nails, it can't change.
I mean, can I ask this fellow here? He said that his knuckles coming back, big background, then I asked the last person, and they said, yeah, that they thought it was them, and they, you know, the number that they said a large back flexibility.
The question I get more often is doctors said they look at the nail and think it's classic looking mycosis, and I think it's fungal. It's got to be fungal. And then they get the reports back and there's not fungal. They say, how can this be? Well, yeah. And what we're telling you is that there's no more accurate diagnostic tool in the world than what we're giving you. So if we tell you we didn't find any DNA from fungal, it's not in there.
So what are you saying?
I'm saying those nails look that way because of a high bacterial load.
And it's MRSA. If it's coming back, Dr. Armstrong, I still got the reports on the nails, still got a lot of nails. It's interesting.
So they're diabetic cases.
They're all I see some MRSA, I see a lot of fungal, I see a lot of alcohol. So when I see a mix with MRSA,
in terms of using linazolid, I hear that point a lot. First of all, antibiotic resistance only becomes from subtherapeutic doses. So the patients who get resistance are the ones that don't take it the full course. You don't get a high enough concentration at the site. So if we're using systemic on a wound, you're going to get resistance because you're not getting a high enough level there to kill it. When you move to topicals, you're putting 500 to 1,000 times the MICs of the antibiotic. So the chance of getting resistance when you apply topical is almost nil. The issue becomes when you use it systemically and you don't achieve subtherapeutic doses.
There was a study done at one of the medical centers. They swapped all their ER. Every time that somebody came in, 22% were positive for MRSA before they entered the ER. So MRSA has become a natural occurring thing. So to find it in about 40 to 45% of your nails is not uncommon. And it won't be once the next studies come out. And that being said, I totally agree with you. Don't waste your time doing oral because it's not going to work. Because those patients that have that also have diabetes, also have vascular disease. So a third of what you're giving them anyway is only getting them to toe. Go with topical, shoot them with 50 to 200% of what you would give them orally.
This was confirmed with the ENT docs, and IDs hate topicals. They really fight adamantly against it. But I say to the IDs, that's great, but there's one group of physicians you're never going to convince to stop, and that's the ENT docs, because they did studies with kids with ear infections, put them on amoxicillin, and they use Cipro drops. The differences in outcome are hugely superior to the Cipro drops. So you can't get an ENT guy to stop doing topical. He's seen that they.
So you're saying continue to take samples of my nails, the methicillin resistant stuff, we're going to come back 40% of the time, and then put them on a topical linazolid and a little.
Well, use laser, use Vanco. You could use.
I mean, but my stars and stripes. I mean, what the hell is the stuff doing with nails?
Was it doing it in the nail?
What's it doing in the nails?
Because the fungus has broken down the natural barrier, and so now anything can work. And MRSA is going to do that. MRSA does that. It's an opportunistic infection. So it's going to do the same thing fungus does. They never MRSA in so many wounds now. It's ridiculous. I did an experiment these guys don't know about. I just swabbed a guy's skin. He had a wound in his groin from a vascular procedure. He had a back in. I didn't want to take his back off and do it. So I said, let me just try something. I swabbed the skin. Just the skin. See if I can do it. I was like, you guys are kidding me.
So you can write something and it's not our fault? I mean, I need something that I put in the term that it's not my fault.
I think the literature is not. Yeah, I mean, I don't think you're at risk.
I don't think you're at risk.
Yeah, that's like, why does this doctor have a high rate of MRSA in her office?
You're not alone.
Yeah,
You're not gonna be court with me like,
the literature stands behind you.
They got to slow down. I always suspect they got to slow down.
That's more reliability.
We don't think we're benefits of the bacterial functions or something.
Diving deeper into
So really rare.
Yes. I mean, they like where on this side, they say,
if you're a family, you're 32. Well, 32 less full.
My new nickname for you is
I know.
DT.
oh yeah, right.
Hallelujah.
From the ancestors. When they said that now we're free out of the antibiotics. It's a huge shift. And what's going to happen when they whenever that occurs?
Okay, so I talked about PCR. There are other labs that do PCR. Your hospital has PCR technology. There's dietetics that does PCR. Nobody does pyrosequencing. That's what we do. That's what we're matching the DNA against a virus. This pyrosequencing comes in right now 5 to 7 days. We just moved to a new platform with technology, so we're going to be looking at 3 to 5 days on your level 2. PCR next day, level 1 next day, level 2, 3 to 5 days. This is a growing petri dish. We have machines now. Okay, here's the report.
Yeah, we don't know what's going on here.
You're telling me, do what I'm doing, don't worry about it, everything's cool. Just don't care if I'm going out.
I'm saying that if you want to provide your patients with, if somebody comes in with a nail and says, Doc, what's causing this? And you want to be able to say, I'll tell you, I'm going to use the highest technology in the world to tell you what's causing that nail. I can't change the fact that it has MRSA in it. But it's the best tool.
See the sad face that I just gave you that you can't tell me that.
I'm sorry, but there's only MRSA in a lot of nails. Yeah.
Alright, thank you.
But I will run the analysis for you. I'll ask you to tell me on 1,000 nails, what percentage of them came back with MRSA?
And print it up so we can put a disclaimer on the card.
I will do that.
Maybe everybody.
Okay. Here's a report. Everybody got enough meat?
No, not yet.
I'll try to get through this quick.
No, we want you to. Yeah, we like that. Yeah.
Okay, so this.
No.
This is what causes the most. We convince doctors to do the sample, and then they get their first report, and they go, oh my God, what the hell is this? I don't know half these pathogens. This is overwhelming.
Were you there when I got it?
There's too much information here. I'm confused. I don't want to do this anymore. Dr. Walcott was telling me the story when MRIs first came out. He said the doctors would say, oh, it's way too much information. I don't need all this. But Now, go to somebody and say, you can't use MRIs anymore, you can only use X-rays. You will get used to it. I mean, but we're going to tell you everything. So, this is I can't even show the whole list. This is a venous leg ulcer. Dr. Carolyn Fife, the editor of the wound textbook. She sent us a lot of samples out of Houston. So, in this case, the bacteria, level 1 came back. We looked for 8 bacteria. So what did we find of the 8? We only found Pseudomonas. If your report comes back with nothing here, but the bacterial load is high, that means we didn't find any of the 8, but we're going to find a lot of stuff on level 2. All right? So in this case, we found Pseudomonas. It was at 10 to the 6. The total load was 10 to the 7. It's really important if you're doing wound care to know the bacterial load. Because you're going to look at the host of the patient and say, I mean, are they getting better? Are they doing progressing? Now all of a sudden, they're stalled, and you look at, oh my God, I got 10 to the 7th bacteria in here. No wonder you're not doing well. The drainage is high. So look at the load first when you're making your decisions. And does cultures tell you the load? So am I convinced you didn't need to know the load?
Yeah.
Okay. So in this case, if we only found Pseudomonas, and say your culture lab got lucky and grew up like iconic Pseudomonas, and then you put them on Cipro or Levaquin for Pseudomonas, right? And you think, oh, I'm all set. I found the pathogen. They didn't give me a culture negative. They found Pseudomonas. I'm putting them on Cipro. Well, lo and behold, they sent it to us, and we said, well, you know what? Pseudomonas was in there, but it was only 5%. The real bad guy is this guy, Fusobacterium. Anybody know what Fusobacterium is? An anaerobe. So, what are the chances of your culture labs growing anaerobes? Slim to none. A lot of anaerobes, Bacteroides, anaerobes, these are all anaerobes. So, what I tell the infectious disease guys who don't like all these 1%ers is focus on the fact that the dominant pathogen. So if you got one at 63%, and look at, if you use, this is going to be a clindamycin, metronidazole augmented, right?
So where's our antibiotics?
I'm going to show you that next. Second page. Next page. But if you use an anaerobic drug, you're going to kill a lot of the other ones too. Okay? Independently.
So what's the lesson there is you have 10 to the 6 Pseudomonas and 25. It's a lot.
Yeah. Oh my God, I can't get this instead of
So, we don't want to leave you with a list of bacteria you never heard of. So, we want to tell you what classes of antibiotics. So we're going to break it down. We're going to tell you, is that pathogen a gram-negative, a gram-positive, is it aerobe, anaerobe, and then which antibiotics can you use against it?
Could you pronounce that bacteria for me the second time?
You can't do it, really.
I can't pronounce it, and you can't treat it.
I'm sorry.
I just want to know.
I can't pronounce it.
Every culture does that
Yeah.
What is that?
Are people lifestyle or personal activities? Because they're coming from
Very bad,
toenails, vaginalis. There's a disconnect there.
That was one thing.
They were talking about
I survived.
what does Dr. White do? Does she treat everything?
Yeah, she uses compound and tolerant.
She's the best
She
job.
made a comment at one of the meetings to her colleagues that said she loves about it is her clinic and smell. It's an extension, anaerobe smell. Anaerobe smell, but
Gentlemen, I get a question a lot when I show these reports. They say, why am I worried about just 1%? And Dr. Wagner actually gave me the answer to that.
The reason why we worry about the 1% is because, first off, everything is synergistic. They all work off of each other. So if you kill the 1%, you have a better chance of killing all the other stuff as well. Secondly, is once you take care of the 63 and the 8 and the 5, your 1% is now your 100%. So you still have to get rid of that. You still have a bacterial load that your body has to fight against. The more you can get rid of that bacterial load, the more your body can focus on not killing bacteria and putting down new granulation tissue, new nerves, and new skin. So that's why, from a vascular standpoint, we kill everything that's on the picture. Anything that comes up 1% or not, we take care of it, get rid of it, and we find a tremendous improvement in the wound versus just killing the big guy and then doing this culture again 3 weeks from now. Because the wound hasn't progressed.
Well, the research also is really interesting. It shows that, my docs tell me, Rick, this wound is not infected. There's no signs of infection. I say, well, here's some UV. Let's take a sample and see what's fine. And it comes back with 10 to the 7 or higher. And they're like, why does it not have the classical signs of infection they have? I'm used to trained to see. We know that some of these guys, what is their job in the colony? These guys actually can go and send messages to the host to say, shut down your inflammatory response. We're not here. We don't want you to kick us out. We're parasites. We need to stay and keep this wound open. It's our food source. So they're very adept over millions of years of figuring out how they can tell the body to shut down the inflammatory response. Don't try to kill us. And you don't know who's doing that. These cells are these bacteria are going to attach to host cells. They can blow them up. But most of them are going to attach and just feed off them, like fleas on a dog. This is just a sinus. Okay, so this is all theoretical in terms of, you can't argue against the science of what's a better tool, culture or DNA sequencing. I mean, you don't need a double-blind randomized trial to prove sequencing is more accurate than culture. You can argue about topical antibiotics, whether they're more effective than systemic and so forth. But Dr. Walcott published a study in 2011 in the Wound Journal with 1,300 patients. And he looked at 3 arms. So the first arm was group standard care was what you guys have been doing unless you've already switched over. Traditional culture was systemic antibiotics. The healing rates were 48%. This was 500 patients. 48%, these are all chronic wounds. So if you look at anybody use Apligraph or Dermagraph? What are their healing rates? 40%, 35%. The comparator is always wet to dry, which is always like 22%, so they look good. So 48% is not out of the realm. The second group, they just changed the cultures to molecular and still prescribed systemic antibiotics, and the healing rates went up to 62.4%. It's intuitive if your diagnostic tool was more accurate, you pick your antibiotics more intelligently, your healing rate should be higher. So if you don't believe in topicals, go ahead and look at this group. When I'm talking to ITs, I cover it up and say forget the topicals, focus on the diagnostics, and take your antibiotics better. But Dr. Walcott's a big advocate in hammering them with high concentration on top of the colony. When he did that, molecular customized topicals, the healing rates were 90%.
I have a question. Did people use topicals and systemic offset time, and that works better, and that's what they suggest?
Dr. Walcott, in reading this chapter, says just that you have to hit with multiple strategies.
Alright. And that's what everyone's doing.
What's that?
Is that the goal of the
Yeah, I mean, in terms of feeding biofilms. Yeah. I mean, you can never take the host out of the picture. You as a clinician have to always look at the host and say what's going on. Are they progressing? How bad is the exudate? If it's, I have docs that, they tell me, say, Rick, I need to sample right away. I have a patient with cellulitis. I'm like, well, you're not waiting for a DNA diagnostic, so I'm on therapy. So you always have to look at the host. The days, you just look, I thought when this study came out, it would turn wound care upside down. But did it make a huge impact? I had an administrator at a hospital tell me, how long does it take doctors to adapt new technology?
2 generations.
8 years. 8 years. So if you're an early adapter, you're going to jump on this. If you're like, I'm still Days to heal, though. Look at this. I mean, a venous leg ulcer. For every, if you work in a wound care center, there's 5 venous leg ulcers for every diabetic foot. The first group at 177 days on heal rates, down to 98 just by changing the diagnostics, down to 37 by hitting it with topical plasma antibodies.
That's from that same study you showed.
That's the breakdown. That's the rare. This is that lady I showed at the beginning. This is actually I worked with a podiatrist in Jacksonville on this case years ago, and this was her after 12 weeks. She was supposed to have a below-the-knee amputation, and she walked out with her foot.
There's no bone involvement.
That's my first question. I asked him, I said, MRI negative? He said, negative. This also is a great case to show you the power of a really good diagnostic tool. This is a 5-year-old leg ulcer caused by a motorcycle accident. This guy was going to the wound care center every week for 5 years. He had everything thrown at him. He had maxed out on his dives. He had a racist, apograph, dermograph. He had ID consult, kit line, everything. Good insurance. Good insurance. Yeah. He had a lawsuit. He actually was a lawsuit. He actually got hit by a police officer in Jacksonville, caused the accident. He didn't have that.
So you did a culture and it came back.
Came back negative, but then we did DNA. The first time I saw it, huge amount of exudate on the dressing. I'm thinking we're dealing with a huge biofilm on this.
Huge.
We sent it off. This is the first case that I had the lab call me, and the guys were asking me, they said, we want to know about this patient.
We're giddy.
Yeah, they're like, why do you care? Never call. And they said, well, he had the highest concentration of a bacteria that we rarely see.
Ever.
Yeah, and we know, and I said, well, what's the name? Like, you guys
They couldn't pronounce it.
I didn't know. And they said to me, when they spray for mosquitoes, there's a bacteria component in the mosquito springs that affects the mosquito bug. This
That
you want to know
sounds like the biggest bullshit I ever heard. Mosquito larvae.
No, in the spray, a lot of pesticides work on, there's a bacteria component
Right.
work on, right?
Okay.
So,
This guy was a sprayer?
no, he worked on a golf course in St. Augustine. He walked into the sun.
So wait, now, so what did you give them? What did you
Hit him with 3 antibiotics.
4.
No,
Topical.
3. Nasal was one of them. Quinda and amikacin, I think, for Quinda is 4. And 5 mix.
Shut up.
Right?
Right. What?
If you don't identify the bacteria, you don't kill it. I'm going to.
Chicken breast.
So, how much does it cost for regular culture? How much? 50, 75, 200. Yeah, it is. Between 175, 200. And that's your basic. If you add anaerobes, if you add fungal, it goes up to 900.
And yours costs how much?
Medicare pays $195.
$195? Oh.
Why can we do it for that price? Why do we do it?
Volume.
We just do
I
it
can
here.
sell for low cost. Volume is at 175 on the culture.
What do you say? 70 over 100? We give you the data.
Still for low cost. Traditional.
Oh, traditional.
Those are the best
Got
ones.
one. All right, I'll take one.
I think I'm done.
You read the other one.
Yes.
The other one. See, that's the one.
You like good actions.
Wait, the underlying part you did not read. I think it's really important.
Oh, whenever we don't want to go into the room thinking, oh, I'd love to do this with DNA thing, but I don't want the patient to get a bill. So,
Right.
we don't take somebody.
I'm gonna send that down.
No one's sure.
We'll run them all. I mean, after 6 months, if you send me only your Medicaid patients after 6 months, I'll probably tell you to stop. I can't do it anymore.
What is it?
And how long does it take a culture to grow? Traditional culture about to grow fungus?
30 days.
No, 7 days. 2 weeks? 21 days. 21 days.
Beautiful, 30 days. 30 to 45 days.
Really?
We're not growing it. Fungus has DNA, so if it's in there, we'll die. That's it.
She changed her mind. She changed her mind.
I have no question.
Yeah.
Is that it?
That's funny you said.
It's over?
Wait, is it? He said, what's
Wait, when's it back? Wait. I have that question.
We didn't look wrong. It was the same old rule, times away.
Very end.